Right now, as you're reading these words, there might be another version of you doing the exact same thing, but in that other reality, perhaps you're wearing a different shirt, or maybe you decided to make coffee instead of tea this morning, or perhaps, in that parallel world, dinosaurs never went extinct, and you're reading this while a triceratops grazes peacefully outside your window. Sound like science fiction? It might not be. In fact, some of the brightest minds in physics are convinced that parallel universes aren't just possible, they're inevitable. And if they're right, then everything we think we know about reality, about choice, about what it means to be unique, might need a complete rewrite. But before we dive into this mind-bending rabbit hole, let's start with a simple question that has haunted humanity for millennia. Are we alone? Not just in terms of alien life, but in terms of reality itself. Is the universe we see, touch, and experience the only one that exists? Or are we just one thread in an infinite cosmic tapestry? The story begins, as many great scientific adventures do, with a curious mind asking uncomfortable questions about the nature of reality itself. Picture this. It's 1957, and a young physicist named Hugh Everett III is sitting in his Princeton office, staring at equations that describe the quantum world. These equations, the mathematical foundation of quantum mechanics, have been bothering physicists for decades. They work perfectly, predicting experimental results with stunning accuracy, but they seem to describe a reality so strange that even their creators can't quite believe it. The problem is measurement. When you're not looking at a quantum particle, it seems to exist in what physicists call a superposition, a ghostly state where it's essentially doing all possible things at once. An electron can be spinning both clockwise and counterclockwise simultaneously. A photon can take multiple paths through space at the same time. It's as if the particle is hedging its bets, keeping all options open until someone comes along to check what it's actually doing. But here's where it gets weird. The moment you try to measure that particle, the instant you peek behind the quantum curtain, it suddenly chooses just one of those possibilities and commits to it. The spinning electron decides to spin either clockwise or counterclockwise, but not both. The photon picks a single path. It's as if the very act of observation forces reality to make up its mind. This phenomenon, known as the measurement problem, had been troubling physicists since the early days of quantum theory. The standard interpretation, championed by physicists like Niels Bohr and Werner Heisenberg, suggested that the act of measurement literally collapses the quantum superposition, forcing reality to crystallize into a single outcome. But this raised uncomfortable questions. What counts as a measurement? Why does observation seem to have such mystical power over the fundamental nature of reality? Young Everett looked at these equations with fresh eyes and came to a radical conclusion. What if, he wondered, the mathematics were telling us something literally true about reality? What if particles don't actually choose a single outcome when measured? What if instead, all possible outcomes actually happen, but in separate, parallel realities? In Everett's interpretation, which would later become known as the many worlds theory, every quantum measurement doesn't destroy possibilities, it splits reality. When that electron is measured, the universe divides. In one branch, you observe it spinning clockwise. In another branch, an identical copy of you observes it spinning counterclockwise. Both versions of you are equally real, equally convinced that they observed the true outcome. But you now exist in parallel worlds that can never communicate with each other. The implications were staggering. If Everett was right, then every quantum event in the universe, and there are trillions upon trillions of them happening every second, creates a branching point in reality. Every time a radioactive atom decides whether to decay, every time a photon chooses which path to take, every time any quantum system makes a choice, the universe splits to accommodate all possibilities. But Everett's peers weren't ready for such a radical idea. The notion that reality literally branches into parallel worlds with every quantum event seemed too fantastic, too removed from everyday experience. His thesis advisor, John Wheeler, was supportive but cautious. The broader physics community largely ignored the work. Everett, discouraged by the reception, eventually left academic physics entirely and went to work for the Pentagon, where he helped develop nuclear strategy during the Cold War. For years, the many worlds interpretation remained a curiosity, discussed in hushed tones by a small group of theoretical physicists who found its mathematical elegance compelling but its implications troubling. But as quantum mechanics matured and our understanding of the universe deepened, Everett's idea began to look less like science fiction and more like serious science. The resurrection of many worlds came from an unexpected direction: cosmology. As physicists began to study the universe as a whole, they encountered new puzzles that seemed to demand equally radical solutions. And slowly, the idea that our universe might be just one of many began to emerge from multiple, independent lines of reasoning. Consider for a moment the curious case of cosmic inflation. In the early 1980s, physicist Alan Guth proposed that the universe underwent a period of exponential expansion in its first fraction of a second. This inflation would explain many puzzling features of our cosmos: why it appears so uniform in temperature, why space seems so flat, why we don't see certain exotic relics that early universe models predicted. Inflation was a beautiful solution to these problems, but it came with an unexpected consequence. According to the mathematics of inflation, this process of rapid expansion doesn't happen uniformly. Instead, it bubbles up randomly, like water boiling in a pot. In most regions, inflation continues indefinitely, stretching space faster than the speed of light. But in some regions, bubbles in this cosmic foam, inflation stops, and a normal universe like ours can form. Here's the kicker: if inflation can create one universe bubble, there's no reason it should stop there. The process continues eternally, spawning bubble universe after bubble universe in an infinite cosmic sea. Each bubble develops its own physics, its own constants of nature, its own story. Most of these universes would be sterile, unable to form stars or planets or life. But in an infinite multiverse, every possibility that can happen will happen, including universes exactly like ours. This idea, known as eternal inflation, suggests that our observable universe, everything we can see with our most powerful telescopes, is just one tiny bubble in an infinite multiverse. Beyond our cosmic horizon, there are other bubbles with different physics, and yes, other bubbles with physics exactly like ours, but different histories. The more physicists thought about this, the more inevitable it seemed. String theory, the ambitious attempt to unify all forces of nature, also pointed toward a multiverse. String theory suggests that the fundamental constants of physics, things like the strength of gravity or the mass of the electron, aren't fixed values, but depend on how extra dimensions of space are curved and twisted. Different configurations of these extra dimensions would create universes with different physics. And in the landscape of string theory, there might be 10 to the power of 500 different possible configurations. That's more possible universes than there are atoms in our observable universe. But perhaps the most compelling argument for parallel universes comes from a puzzle that has nothing to do with exotic physics and everything to do with our everyday experience of being alive. The puzzle is this: our universe seems suspiciously well-tuned for life. The laws of physics contain about 20 fundamental constants, numbers like the strength of the electromagnetic force or the mass ratio between protons and neutrons. These numbers appear to be arbitrary. As far as we know, they could have any values. But here's the strange thing: if any of these constants were even slightly different, the universe would be a very different place. And by very different, I mean completely inhospitable to life. Change the strength of the strong nuclear force by just a few percent, and atomic nuclei couldn't hold together. Make gravity slightly stronger, and stars would burn out too quickly for life to evolve. Adjust the mass of the electron by a small amount, and chemistry as we know it becomes impossible. The universe seems to be balanced on a knife's edge, with all its constants precisely tuned to allow the existence of stars, planets, and ultimately, us. This fine-tuning problem has troubled scientists for decades. Some see it as evidence for a creator, a cosmic designer who carefully adjusted the dials of physics to make life possible. Others find this explanation unsatisfying and have looked for alternatives. The multiverse offers one such alternative. If there are truly infinite parallel universes with different physical constants, then most of them would indeed be sterile and lifeless. But in an infinite multiverse, there would also be universes with just the right combination of constants to allow life to emerge. We don't observe a finely tuned universe because some designer made it that way. We observe a finely tuned universe because we could only have evolved to observe ourselves in a universe capable of supporting our existence. This line of reasoning, known as the anthropic principle, suggests that the apparent fine-tuning of our universe might be nothing more than a selection effect. Just as a puddle might think the pothole it sits in was designed perfectly for its shape, we might think the universe was designed for us, when actually we simply evolved to fit the universe we found ourselves in. But the anthropic principle raises its own troubling questions. If there are infinite parallel universes, then there are also infinite versions of you. In fact, if space is truly infinite, something many cosmologists believe, then there are infinitely many regions of space with exactly the same arrangement of matter as our observable universe. Somewhere out there, in the vast cosmos, there's another planet Earth with another version of you reading these exact same words. How far away might such a duplicate be? The calculation is mind-boggling but straightforward. In our observable universe, there are roughly 10 to the power of 80 atoms arranged in specific ways. The number of ways to arrange 10 to the power of 80 atoms is enormous, but finite. This means that if you travel far enough through space, about 10 to the power of 10 to the power of 29 meters, a distance so vast it defies comprehension, you would eventually find a region with exactly the same arrangement of atoms as our observable universe. There would be another Milky Way, another Earth, another you, and this is just the beginning. In an infinite universe, there aren't just duplicates of you, there are infinite duplicates, living infinite variations of your life. There's a version of you who became a professional athlete, a version who moved to Japan, a version who was born in medieval times due to random quantum fluctuations that delayed human evolution by centuries. There are versions of you living every possible variation of your life that's consistent with the laws of physics. The philosophical implications are staggering. If every possible version of your life is being lived out somewhere in the multiverse, what makes your experience special? When you make a choice, say, to read this article instead of watching television, are you actually making a choice, or are you simply becoming aware of which branch of reality you happen to inhabit? In one universe, you chose to read. In another, you chose to watch TV. Both choices were made. Both versions of you are equally real. So what did you actually choose? These questions become even more perplexing when we consider quantum mechanics. If the many worlds interpretation is correct, then every quantum event splits reality. But quantum events are happening constantly at the subatomic level, in every atom of your body. This means that reality is branching continuously, creating new versions of you trillions of times per second. Right now, as you read this sentence, quantum events in your brain are determining which neurons fire, which thoughts occur to you, how you interpret these words. In some branches of reality, a cosmic ray hits your brain just right and causes you to have a sudden insight. In others, a quantum fluctuation changes the chemistry of a synapse, and you lose interest in this topic entirely. Most of these quantum events make no measurable difference to your experience, but some might. And in the many worlds interpretation, all possibilities play out in parallel realities. The strange thing is that from your perspective, you only experience one branch. You feel like a single, continuous self making choices and having experiences. But according to many worlds, you're actually more like a tree, constantly branching into multiple versions of yourself, with each branch convinced that it's the real you. This raises a profound question about the nature of identity and consciousness. If there are countless versions of you scattered across parallel worlds, which one is the real you? The answer might be all of them. Each version has an equal claim to being you, with the same memories, up to the point of branching, and the same sense of continuous identity. But here's where things get really weird. Some physicists have suggested that quantum mechanics might allow for communication between parallel worlds under very special circumstances. The idea is that if quantum systems in different branches of reality remain entangled, connected in a way that Einstein famously called spooky action at a distance, then it might be possible for information to leak between worlds. One of the most intriguing possibilities involves quantum computers. These devices use quantum superposition to perform calculations that would be impossible for classical computers. According to the many worlds interpretation, a quantum computer doesn't just perform one calculation. It performs the same calculation simultaneously in many parallel worlds, then somehow aggregates the results. David Deutsch, a pioneering quantum computer theorist and a strong proponent of many worlds, has argued that quantum computation is actually computation performed by collaborating computers across parallel universes. When your quantum computer factors a large number, it's not just one machine doing the work. It's exponentially many machines in parallel worlds working together to solve the problem. This idea suggests something remarkable. We might already be interacting with parallel universes without realizing it. Every time a quantum computer performs a calculation, it might be reaching across the multiverse to harness the computational power of its parallel selves. But the implications of the multiverse extend far beyond physics and computation. They touch on some of the deepest questions about human existence, morality, and meaning. Consider the nature of probability and chance. In a single universe, events have probabilities. A coin flip has a 50% chance of coming up heads. But in the many worlds multiverse, every coin flip produces both outcomes. The coin lands heads in some branches and tails in others. From the perspective of the multiverse, nothing is truly random. Everything that can happen does happen. This has led some philosophers to argue that in a many worlds multiverse, nothing truly matters because every possible outcome occurs somewhere. If every choice you make is also not made in some parallel world, if every life you save is also lost elsewhere, if every achievement you accomplish is also failed in another branch, then what's the point of trying? But others argue for the opposite conclusion. If you are just one branch in an infinitely branching tree of selves, then your choices matter immensely, not because they're the only choices being made, but because they determine which branch of yourself you become. You can't control what happens in other branches, but you have complete control over which version of yourself you become in this branch. Moreover, if there are infinite versions of you making different choices, then your moral responsibility might be even greater than in a single universe. In some branches, versions of you might be making selfish or harmful choices. In others, versions of you are being exceptionally generous and kind. The question becomes, which version of yourself do you want to be? The multiverse also offers a new perspective on some of humanity's oldest questions about fate and free will. In a single universe, there's an ongoing debate about whether free will is real or illusory, whether our choices are genuine or simply the inevitable result of prior causes. In the multiverse, this debate takes on a different character. If many worlds is correct, then in some sense, you don't choose which action to take. Instead, your choice determines which branch of reality you experience. When you're faced with a decision, All possible choices are made by different versions of you. But the choice still matters because it determines which version of yourself you become conscious of being. This perspective suggests that free will isn't about having the power to change the overall structure of reality. All possibilities happen regardless. Instead, free will is about having the power to choose which thread of reality you follow, which story you tell with your life. The multiverse also provides a new framework for thinking about death and mortality. In a single universe, death is final. When you die, your story ends. But in an infinite multiverse, there are branches where every possible version of your life plays out. There are branches where you live longer, branches where you die earlier, branches where medical science advances fast enough to prevent your death. Some physicists and philosophers have even speculated about quantum immortality, the idea that from your own subjective perspective, you might never experience death. The reasoning goes like this. In any situation where you might die, there are quantum events that could save you. A cosmic ray that disables the gun pointed at you. A quantum tunneling event that moves you slightly out of the way of a fatal accident. These events are incredibly unlikely, but in the many worlds multiverse, they happen in some branches. If consciousness can only continue in branches where you survive, then from your own perspective, you would always find yourself in the improbable branches where you lived. You would experience an increasingly unlikely but unending series of close calls and miraculous survivals. To outside observers in branches where you died, you would be dead. But from your own subjective experience, you would be immortal. This idea remains highly speculative and controversial even among many worlds proponents, but it illustrates how the multiverse challenges our most basic assumptions about life, death, and the nature of experience itself. The scientific evidence for parallel universes remains indirect but growing. We can't directly observe other universes. By definition, we're causally isolated from them, but we can look for their indirect effects on our own universe. One area where physicists are searching for multiverse evidence is in the cosmic microwave background, the afterglow of the Big Bang that permeates all of space. If our universe collided with another universe bubble in the distant past, it might have left a signature in this background radiation. Several research groups have claimed to find suspicious patterns that could be evidence of such collisions, though these results remain controversial. Another potential source of evidence comes from quantum mechanics itself. Some interpretations of quantum mechanics predict subtle deviations from standard quantum predictions that could be tested experimentally. If these tests show results consistent with many worlds, but inconsistent with other interpretations, it would provide strong evidence for the multiverse. Perhaps the most ambitious search for multiverse evidence involves looking for signs of fine-tuning that are too precise to be coincidental. If we discover that certain physical constants are not only life-friendly, but optimized in ways that would be extremely unlikely in a random universe, it could suggest that we're in a particularly special branch of the multiverse, perhaps one that has been influenced by the existence of intelligent life itself. But even if we never find direct evidence for parallel universes, the concept has already transformed how physicists think about reality. The multiverse provides elegant solutions to some of physics' deepest puzzles: the measurement problem in quantum mechanics, the fine-tuning of physical constants, the nature of probability and randomness. More importantly, the multiverse concept has opened up new ways of thinking about old questions. It's forced us to reconsider what we mean by real, what constitutes evidence, and how science should deal with ideas that might be true but unprovable. The journey from Everett's lonely thesis to today's serious scientific discussions of the multiverse illustrates something profound about how science works. Good ideas in science are rarely accepted immediately, especially when they challenge fundamental assumptions about reality. But if an idea is mathematically sound, if it explains observations better than alternatives, and if it makes testable predictions, it eventually gains acceptance regardless of how counterintuitive it might seem. The history of science is filled with ideas that once seemed absurd but are now accepted as obvious truths. The Earth orbits the Sun, not the other way around. Time and space are relative, not absolute. Matter is mostly empty space with tiny particles zipping around inside. Each of these ideas was initially rejected by the scientific establishment because it challenged common sense. The multiverse might be the next such idea. Today, it seems fantastical to suggest that there are infinite copies of you living infinite variations of your life across parallel worlds. But perhaps future scientists will look back at our current skepticism the way we now look back at those who couldn't accept that the Earth moves around the Sun. Or perhaps not. Science is ultimately about following the evidence, wherever it leads. If future experiments definitively rule out the multiverse, then physicists will abandon the idea and look for better explanations. That's how science progresses, through constant testing, revision, and refinement of our understanding. But there's something deeply appealing about the multiverse that goes beyond its scientific utility. In a single universe, we're faced with the sobering reality that our lives are brief, our influence limited, our significance uncertain. We make choices, but we can never know what would have happened if we had chosen differently. We live one life, follow one path, experience one tiny slice of all possible experiences. The multiverse offers a different perspective. If parallel worlds exist, then in some sense, you do get to live every possible version of your life. Every path not taken in this world is taken in another. Every opportunity missed here is seized elsewhere. Every version of yourself that you might have become actually does become somewhere in the vast landscape of parallel realities. This doesn't diminish the importance of the choices you make in this world. If anything, it amplifies them. In the multiverse, your choices don't just determine what happens in one universe. They determine which universe you experience, which version of yourself you become conscious of being. But the multiverse also offers comfort in the face of life's inevitable losses and regrets. That career you never pursued, that person you never met, that place you never visited. In the infinite branching of parallel worlds, versions of you experienced all of these things. The totality of who you are isn't limited to the single thread of experience you're conscious of in this moment. It's the entire tree of all possible yous across all possible worlds. Some find this idea terrifying, the notion that there might be infinite versions of themselves, including versions doing terrible things or experiencing terrible suffering. Others find it liberating, the realization that they are part of something vast and multifaceted, that their existence extends far beyond their individual experience. As we stand on the threshold of potentially discovering whether parallel universes are real, we're forced to confront fundamental questions about the nature of reality, identity, and meaning. These aren't just abstract philosophical puzzles. They're questions that could reshape how we understand our place in the cosmos. If the multiverse is real, then we are simultaneously more significant and less significant than we ever imagined. Less significant because we're just one branch among infinite branches, one story among infinite stories, but more significant because we have the power to choose which branch we follow, which story we tell, which version of ourselves we become. The search for parallel universes represents something uniquely human, our relentless drive to understand not just how the world works, but what it all means. We're not content to simply exist. We want to know why we exist, how we fit into the bigger picture, whether we're alone or part of something larger. Whether parallel universes exist or not, the very fact that we can conceive of them, mathematically describe them, and seriously consider their implications says something remarkable about the universe we find ourselves in. We live in a cosmos that has produced beings capable of contemplating infinity, of imagining realities beyond their own experience, of asking whether their single life might be part of an infinite multiplicity. In some sense, we're already living in a multiverse of possibilities. Every day, we're faced with choices that could lead our lives in different directions. Every moment, we're selecting which path to follow through the space of all possible experiences. The multiverse of physics might be real or imaginary, but the multiverse of human potential is undeniably real, a vast landscape of possibilities stretching out before each of us. As you finish reading this exploration of parallel universes, take a moment to consider the path that led you here. The choices you made, the circumstances you encountered, the quantum events in your brain that made you curious about this topic, all of these factors combine to create this moment of understanding. In the vast space of all possible lives, you followed the thread that led you to contemplate the possibility that there might be infinite other threads, infinite other yous, infinite other realities, and perhaps, somewhere in a parallel world, another version of you is just beginning to wonder about the nature of existence, about to embark on their own journey into the mind-bending possibilities of the multiverse. The questions that end one story become the beginning of another, in an endless cycle of curiosity and discovery that might span not just one universe, but all possible universes. In the end, whether we live in one universe or infinite universes, the most remarkable fact remains unchanged. We are part of a cosmos capable of contemplating itself, of questioning its own nature, of imagining possibilities beyond immediate experience. We are the universe's way of asking questions about itself, and that might be the most extraordinary parallel reality of all. The story of parallel universes is still being written, not just in the equations of theoretical physicists, but in the choices we make, the questions we ask, and the realities we choose to explore. Whether there are infinite versions of you or just one, whether reality branches or follows a single path, the universe we experience is shaped by our curiosity, our wonder, and our endless desire to understand our place in the vast cosmic story. And that story, our story, your story, the story of consciousness contemplating infinity, is perhaps the most remarkable tale in any universe, parallel or otherwise.